Good morning, class 11. Children, in yesterday's video lecture, I started with the concept of quantum numbers. It is an integral part of quantum mechanical model of atom because the concept of quantum numbers takes you to the location of electron in an atom. And to know the location of an electron in an atom, I told you that there are few things that you need to know, and those things, about the idea about those things, we get to know from the quantum numbers. So I told you that in order to locate an electron in an atom, first of all you need to find out the atom in which you are looking for the electron. Then you move into the shell, then you move into the subshell, and then you move into the orbital, and then gradually to the electron. The shell number is indicated by the principal quantum number. Subshell information is given by azimuthal quantum number. Orbital information is given by magnetic quantum number. Then we reach to spin quantum number, which tells us about the orientation of the electron, that how is the electron located in an atom. Orientation means the electron spin is actually indicated like this or like this. So this is the spin of the electron, whether parallel or anti-parallel. This information is conveyed by spin quantum number. So I discussed with you the principal quantum number in yesterday's session, where I told you that principal quantum number gives us the information about the shell number, and apart from telling us about the shell in which the electron is present, it also tells us about the energy of the electron and also about the size of the shell. And if you remember, children, when you move away from the nucleus, the energy increases and reaches to a maximum value. And similarly, the atomic radii also increases when you move away from the nucleus. So these were the topics we did yesterday. Now in today's session, I am going to tell you about another second very important quantum number, azimuthal quantum number. Azimuthal quantum number is indicated by L. And the information that we get from azimuthal quantum number is, it tells us about the subshells. First thing is, it tells us about the subshell to which the electron belongs, electron is not visible there. It tells us about the subshells to which the electron belongs. It tells us about the shape of the orbitals. Another very important information that we get from azimuthal quantum number is about the shape of the orbital. So first of all, let us see how do we come to know about the subshell. The formula to find out the value of L is equal to 0 to n minus 1. So one shell can have more than one subshells. One shell can have more than one subshells. Remember this. And the values of subshell we get from this formula, where L is equal to 0 to n minus 1. And n is what? N is the value of principal quantum number, which is equal to what? Shell number or energy level number. So according to the formula, if the value of n is 1, children, I request you, while understanding these concepts, while going through these videos, please carry a pen and a copy along with you so that you can also write along with me. Pause the video, try to do certain calculations on your own. It is very important. You have to be very attentive while listening to these sessions. So let us see this with the help of an example, children. If n is equal to 1, then what are the possible values of L? L will be equal to 0, because it will begin from 0. 0 to n minus 1 means 1 minus 1, which will be 0 only. So it will be equal to 0 only. Now if the value of n is equal to 2, then the possible value is 0, 1. And if suppose the value of n is equal to 3, then what are the possible values of L? It will be 0, 1, 2. Similarly, if n is equal to 4, then the possible values will be 0, 1, 2 and 3. These will be the possible values. So I hope how to find out the value of L when n is given is clear to you. The subshells corresponding to different values of L are as follows. Now you have to remember, children, these 4 subshell notations also when the value of L is known. If the value of L is 0, the subshell is S. and the shape of S is spherical. If the value of L is 1, it is P. The shape of P is dumbbell. And if the value of L is 2, it is equal to, the notation is D. Okay, D. And the shape is double dumbbell. The shape of double dumbbell except dz square I'll explain you later, because when I'll talk about orbitals then I'll tell you. So 2 means D subshell, and the shape is double dumbbell. If the value of L is 3, it means the subshell is F and the shape is complex, which cannot be mentioned on the notebook. So it is a complex shape. Again repeating the same thing. Value of L, if it is 0, then the subshell is S. Actually subshells are S, P, D, F. Remember this, S, P, D, F are the 4 subshells that you have to study, and these 4 subshells can be, you can find out the values or the notations of these subshells depending upon the value of L. If the value of L is 0, it is S. If it is 1, then it is P. If it is 2, it is D. If it is 3, then it is F. So similarly, if it is 4, then the subshell is G. At the max, you can get the question up to 4. Fine. You don't have to do the shape of it. So S subshell is spherical, and P is dumbbell like this. D is double dumbbell like this. I'll discuss the shape in detail later on. And it is complex. F is complex, so the shape is not mentioned in your books. Now what are these, what is the meaning of these terms? S means sharp, P means principal, D means diffused, and F means fundamental. Okay, these are the full form of these abbreviation. S is sharp, P is principal, D is diffused, and F is fundamental. Now again writing the entire thing which you have done till now in detail in showing the notations. So here is a table which has the value of n as 1, 2, 3, 4. Now with the help of n, what will be the values of L? L is always equal to the number, L is always equal to 0 to n minus 1. So what will be the value of L when the n is equal to 1? It will be equal to 0. For 2 it will be 0, 1. For 3 it will be 0, 1, 2. For 4 it will be 0, 1, 2, 3. You can see here that the numbers here is equal to the number of subshells. Okay, the first shell has only one subshell. The second shell has 2 subshells. The third shell has 3 subshells. The fourth shell has 4 subshells. Now how will you represent this subshell? It is represented together. Okay, 0 means S, so you can write it together as 1S. See, it is written as 1S. And with respect to second shell, it can be written as 2S and 2P. 0 means S, 1 means P. So it can be written as 2S, 2P. You can see here. And this means 3S, 3P, 3D. 3S, 3P, 3D. And this will be equal to 4S, 4P, 4D, 4F. You can see here. So these are the representation of subshell along with the shell. Very, very important, children. You have to make it clear in your mind, children. We will be dealing with these in rest of the chapters. So please make sure that it is clear to you. So again, coming to it, remember this first of all, 0, 1, 2, 3, 4 are SP, D, F, G. And you will be getting most of the time the question up to F or at the max G. And N is the shell here, L is the subshells. And here I have already given you the formula to find out the value of subshells, and here is the notification, how it is notated. So it is 1S, 2S, 2P, 3S, 3P, 3D, 4S, 4P, 4D, 4F. You can also calculate the angular momentum with the help of the value of L. Angular momentum can also be calculated using the formula under root L into L plus 1 into h upon 2 pi. Time you can also get the question to calculate the angular momentum. I told you that angular momentum is represented by L, which is equal to under root L. If suppose the value of L is 0, then substitute the values, the angular momentum will come out to be 0. If L is 1, substitute the value, will come out to be root 2 h upon 2 pi. L equals to 2, then the value will be root 6 h upon 2 pi. And if it is 3, then value will come out to be root 2 h upon root 12 h upon 2 pi. So like this you can find out the value of angular momentum. Please remember this formula for calculation of angular momentum, which is represented by capital L. Okay, I hope this much is clear to you. Now coming to the next quantum number, that is magnetic quantum number. It is not visible here children, but you can put the heading as magnetic orbital quantum number, which is represented by ML or simply M. Okay, please put the heading magnetic quantum number. So what is the information that we get from magnetic quantum number? It gives us or tells us about the total number of orbitals present in a given subshell. Shell contains subshell and subshell contains orbitals. So this magnetic orbital quantum number tells us about the total number of orbitals present in a given subshell. I hope you are writing also along with me. Okay, please mention the heading here, magnetic quantum number. It describes the behavior of an electron in the magnetic field, and we have the formula to find out the magnetic quantum number, which is equal to 2L plus 1. So if you have the value of M, you can find out the value of magnetic quantum number if you have the value of L. So N helps you to find out the value of L. L will help you to find out the value of M, that is number of orbitals. So if suppose the value of L is 2, then magnetic quantum number will be equal to 2L plus 1, that is 2 into 2 plus 1 will be 5. Or and also you have to remember that value of M is equal to plus L to minus L. That means if you are right, if the value of L is given as 2, then the values of M will be plus 2, plus 1, 0, minus 2, minus 1, minus 2, and these total, how many total magnetic quantum numbers you can see here? 5. That is why the answer is 5. And if you have to mention the values of magnetic quantum number, what are those 5 values of magnetic quantum number, then you can mention it like this. Okay, our total number of orbitals is 5 and values of orbital is mentioned here, which is equal to plus L to minus L. This means that D subshell contain 5 orbitals. L equals to 2 means we are talking about D subshell, and this indicates that D subshell has how many orbitals? It has 5 orbitals. You have to learn these things. I mean, for now though you can calculate, but for later on application you should be thorough. The moment you see D or subshell, that means it has how many orbitals? 5 orbitals. For S subshell, now coming to S, the value of L is what? 0. Now substituting the value of L 0 here, what will you get? 2 into 0 plus 1 will be 1. So the value of M for this will be 1. That is, only one orbital is there, and what is the value of that orbital? 0. Okay, so S subshell with L equals to 0 contains only one orbital, which I mentioned here. For P, where L is equal to 1, the values of M possible is minus 1, 0, plus 1. And if you substitute the value to calculate the number of orbitals, it will be equal to 2 into 1 plus 1. This will be equal to 2 into 1 is 2 plus 1 equals to 3. So how many orbitals do P subshell have? It has 3 orbitals. How many orbitals? It has 3 orbitals, and the values are minus 1, 0, 2, plus 1. And F L equals to 3, the values will be minus 3, minus 2, minus 1, 0, 1, 2, 3. Now substituting the value in the formula, you will get 7. This is what? This is equal to the total number of orbitals that F subshell has, and the values are mentioned here. So with the help of these, I have a table here. Value of L is equal to 0, 1, 2, 3, 4. Subshell is equal to S, P, D, F, G. Number of orbitals, how many? S will have 1 orbital from the above calculations. P will have 3, D will have 5, F will have 7, and G will have 9. So these are the important informations that we get from magnetic quantum number and the other two quantum numbers. Thus, this quantum number explained the splitting of a single spectral line of hydrogen into a number of closely spaced lines in the presence of electric field, Stark effect, and magnetic field. Zeeman effect, because as of now we know that electron atom does not only have shell, it also has subshell and orbitals. Okay, so as of now we have seen that orientations of electrons change in the magnetic, leading to the degeneracy of subshells. Degeneracy means having equal energy. Okay, or you can say splitting here with equal energy of these subshells. I'll explain you these in detail. See, these things are new to you children, you might find it difficult, but once you will be thorough with it, you will enjoy solving the quantum numbers. Okay, again telling you about it. So this quantum number, basically this quantum number told us that the hydrogen spectral line undergoes splitting when it is introduced to magnetic field and electric field, because an electron has various magnetic orientations, which we can see with the help of magnetic quantum number. You saw that for one value, for one particular, suppose F or F subshell, we saw that there are these particular orientations which are possible, 7 orbitals. That means each subshell is splitted into so many orbitals. Okay, now the last one is electron spin quantum number. Now electron spin quantum number, the above three quantum numbers explains the energy, shape and orientations of the orbital. Spin quantum number specifies the spin of electron, which is either plus half or minus half. It also tells that a single orbital can contain only 2 electrons with opposite spin. A single electron cannot have a single orbital cannot have more than 2 electrons. A single electron can only contain 2 electrons. Very, very important. Now taking you to some more details children. If suppose I am talking about S subshell here, then we have P subshell, D, F. Okay, these are the 4 subshells, and subshells we get from the azimuthal quantum number, the information about subshells. Okay, and we calculated right now that the value of M for S is what? 1. It has 1 orbital, P has 3 orbital, D has 5 orbital and F has 7 orbital. These values we have learned how to calculate. Then how to show these orbitals? What is the method of showing this orbital? The orbitals are shown like this box. S has 1 orbital, so 1 box. P has 3 orbitals, so 3 boxes. D has 5 orbitals, so we'll show 5 boxes here. 1, 2, 3, 4 and 1 more, 5. Okay, it has 7, so you'll show 7 boxes. 1, 2, 3, 4, 2, 3, 4, 5, 6 and then 7. 1, 2, 3, 4, 5, 6, 7. Okay, so this is represented by, thus orbitals are represented as these boxes. The value of this is 0, using a different pen. For this it will be equal to 0, plus 1, minus 1, and for this we know that for S the value of L is 1. Sorry, it is 0. For this it is 1. For this it is 2, and for F it is 3. So this is equal to minus L to plus L. So this will remain 0, and in this case it will be minus 1 to plus 1. For this it will be minus 2 to plus 2. For this it will be minus 3 to plus 3. So I hope this is clear to you. Now we know that, just now I told you that each orbital can have at the max 2 electrons. So total electron holding capacity of each shell can also be calculated. So if I talk about S subshell here, okay, if I am talking about S subshell, then S subshell has only one box. That means total electrons it can hold is 2, and it has 3 boxes, so total electrons it can hold is 6. D has 5 boxes, so total electron it can hold is 10. F has 7, so total electrons it can hold is 14. So like this you can also find out the maximum electron holding capacity of each subshell. So in short, you got the information about shell, subshell, about orbital, about the number of electrons in each orbital. These topics are very important, children. We will be doing some more numericals and questions based on the concept of quantum numbers. And for now, children, you watch the video properly, revise the concepts, and please post your doubts to me. Tell me your doubts if you are having any. I know these topics are new. It is very obvious that you might have little bit of difficulty in understanding it at once. You can watch the video twice or thrice, and then in case of any doubt, please children tell me so that I can help you out. Thank you for watching the video.